Two equal chords of a circle intersects. Prove that the parts of one chord are separately equal to the parts of the other chord. So this is something that you guys have to draw and think what is that we have to prove. It's a good question. So figuring out what is the diagram and that is basically how it looks, and what is that we have to prove is very important. Proving is not that difficult. Okay, I hope you guys figured it out. Now we are looking at two chords, right? But there is a speciality. What is it? They're equal in length, yes, and they intersect each other. So basically something like this. So you can see that I've almost drawn two equal chords, and you can see they are intersecting. And what is that we have to prove now? Yeah, now at least figure it out. We have to prove that. Let me actually start off with the writing part. By the time you guys can think. Let's consider a circle with center O. I'm calling that as O. Then we'll talk about, let AB, PQ be the chords, of equal length and intersecting at M. Hanji. Abhi, you have to talk about what is that we have to prove. Please tell. Yes, we have to prove that AM is equal to PM and QM is equal to BM. Okay, yes, that's what we have to prove. So basically, these two lengths are equal, or these two lengths are equal. If I prove one of it, by default the other one can be proved. Okay, so your proof should look something like this. This is a bit of construction, and that would be what? Yes, join OM. Then also after this we have, okay, let me start off from here. Draw perpendicular lines from O to the chords. So let's draw that. So these two are perpendicular. I'll call this as T and R, I guess. Yeah. OT and OT perpendicular to AB and OR perpendicular to PQ. Okay. And now you can pause and think over how do you prove. Next clue is we have one more construction, and that would be joining OM. Oh, I already told, sorry. I didn't draw that. Did you guys get how to do this? It's quite simple. Yes, we have to make use of congruency. Which two triangles? It's kind of obvious. OTM and other one is OMR. So what do we have here? We have proof. Oh. Proof in triangle OTM and triangle ORM. So let's see. I think I can prove it to be congruent. OM is common. Then we have OT is equal to OR. But why? And how? The same thing actually. Which theorem is it? Yes, it's there in front of you. Think. Equal chords of a circle are equidistant from the center, right? So we need to write the reasoning. Equal chords of a circle are equidistant from center. Okay, yes. And end of it, what else do we have? We have the hypotenuse, we have one of the side, and we just have to tell OTM, angle OTM is equal to angle ORM. Both are equal to 90 degree. Reason being OT is perpendicular to AB and we have OR perpendicular to PQ. So with all of this, what can you conclude? Therefore, by RHS congruency, we have triangle OTM congruent to triangle ORM. OTM ORM, yes, ORM. And with this, what can we tell? With this, we can tell that TM is equal to MR. But how is this useful? By CPCT, TM is equal to RM or MR. How is this useful now? How can we make use of this and prove the remaining of the question? Think about it. So we just prove that you guys got now these two lengths are equal. Yes. The proof continues this way. AB is equal to PQ given. Now we'll divide both the sides with 2. So what happens? We have AB by 2 which is equal to 80 and equal to TB, and also we have PQ by 2 which is equal to PR and RQ. But why is this so? The reason being the following: perpendicular from the chord from the center to a chord bisects it. Okay guys, so we have OT to be equal to RP, right? Therefore not OT, sorry, AT to be equal to RP or something, RP, yeah. And with adding 1 and 2, we'll add 1 and 2. So what will we get? So on adding 1 plus 2, AT plus TM is equal to PR plus RM. What is AT plus TM? Obviously it will be AM. And this is PM. Okay. So we have AM and PM to be of equal length. We're almost there. And now we'll subtract equation. The next part is quite simple. AB is equal to PQ. So we'll call this as B and this is A. So what should we do? Think of it. It's quite simple. I just told it. Yes, we will subtract it. Equation B minus A will give us AB minus AM, which is equal to PQ minus PM. So as a whole, what do we have? We have BM is equal to QM. And we have proved. Okay, it's a good question. There's a lot to learn and understand and get familiar with. Yeah, so the entire question is a star.